This presentation is delivered by the Stanford Center for Professional Development.
That said, are there any questions about classes right now, just a priori, anything we've done? I want to spend a little bit of time touching on classes before we dive into our next great topic today, which is graphics. So if we actually have the computer for a second, I just want to briefly review the class that we wrote last time, right? So we wrote a class that hopefully is near and dear to many of you because many of you are instances of this class, which is a student, right? And we went through and we talked about all the things that you actually want to have in a class, and hopefully this is just review. You have some constructors in the class. You can have multiple different constructors in the class. But here we just have one where we take in a name and an ID. And that name and ID gets set to some instance variables or IVARs that all students have, namely student name and student ID. So I'll scroll down to the bottom. And here we have our private instance variables. Student name, student ID, and units earned. These are the variables that every student object has their own copy of. That's why they're instance variables as opposed to, say, a class variable. This guy over here, because it's got a static, is a class variable. Because it's got a final, it's actually a constant, as hopefully you've seen many times by now. And so all students share units to graduate as the same constant value, 180. Okay, so it's both a constant and a class variable. Most things that are constants make sense to be class variables because all elements of that class sort of share the same constant value. All students require 180 units to graduate. Okay? So we did a bunch of things in here. We kind of went through the constructor. We went through a few places where we said, hey, if you want to be able to access portions of this class which are private, you can't directly access them from outside, right? That's why they're private. So no one can touch your private parts. And so what you needed to have was you needed to have these functions if you wanted to allow people to access them that we refer to as getters. And the reason why we refer to them as getters is because they start with the name get. And what they do is they're public methods, so someone can actually call these methods from outside of your class, and they just return the value for some appropriate thing that the person would want, like get ID would return student ID. Now you might say that's kind of weird. Why do I have these getters when student ID I could just make public and let people access it directly? Why would I do this? So you can't change it, right? If student ID was public, that's a public variable. People can not only read what the value is, they can set what the value is. If I make it private, I control access to it. And here, I could let you read what the ID is by giving you a copy of the ID. I don't let you set it. The only way the ID actually gets set is when a student first gets created and you get a student ID up here, which you have for life. So when you get created, you have the ID for life. This is actually true at Stanford. As a faculty member now, I have the same ID number, no joke, that I had when I was a student. It's kind of funky. And they're just like, you are in our universal system, and you will be here for the rest of your life. And it doesn't matter if you go away, and then when you come back, you will still be that same ID number because you can never change it once you're created. Same kind of idea going on over here with this class. Okay? Now, sometimes we do allow someone to change something, and we'll have what we call setters as well. So for units, we not only have get units, which returns the number of units earned, we also have what we refer to as a setter, which sets the number of units. And you might say, okay, that's kind of odd, Maron. If you're allowing someone to set the units and get the units, why don't you just make that variable public, right? Because at this point, you're allowing someone to both set its value and get its value. What else are you going to do with that variable? And the reason why we still don't make it public is because of information encapsulation. The person who's getting the number of units you have and setting the number of units you have doesn't need to know how we keep track of that information. It could actually turn out that the way we get your units is we go through your whole transcript and total up all your units, and we never actually store it as one value, and that's how we get it back for the person. And when they try to set it, if they try to set more units than you already have, we just create some dummy classes, or if they try to reduce the number of units, we drop some of your classes. It happens occasionally. So it doesn't matter how it's implemented underneath the hood, right? It's information hiding. All the person needs to know is that they can get it and set it. In this case, it's simple because it is just referring to one variable. And you'll see that oftentimes is the case, but not always, which is why we still have this encapsulation. And so for some things, we have getters and setters. Okay? And then there was a few other things here where we could increment the number of units someone has, or we could check to see if they have enough units to graduate by just checking if their unit count is greater than graduating the number of units they need to graduate. And last thing, which I said all classes need, and again, I will repeat this because all classes you write that are not programs, so any classes you write that does not extend, say, console program or graphics program should always have something called toString. String is just text, and what this does is it returns basically some piece of text that tells the person using this class what this object actually encapsulated. It doesn't need to contain all the information in the object, but here we're going to return the student's name and then the student ID number inside parens. Okay? So that's a quick review of the class, and part of the reason I want to do a quick review is we're actually going to extend this class, which means, remember when we talked about classes in the days of yore and we had classes and subclasses and superclasses? Here's a student. All of you are students. Now, there are some specializations of student as well. As a matter of fact, some of you are, for example, frosh, which is a kind of student. And some of you are sophomores. And some of you are juniors. And some of you are seniors. The size of the box doesn't actually mean anything other than, it's smaller. Some of you are grad students. Some of you are the dreaded other student. We won't talk about that. We'll just call you the other student. Because occasionally you may not be any of those things and we still need a way of keeping track of you. But all of these things are classes which are specializations of student, which means you have all the properties that a student does and perhaps some special properties that you may have by being in one of these particular classes. Okay? So let's actually write one of these. Let's write the frosh subclass. How many people in here are freshmen, frosh? Woohoo! So hopefully I picked the majority class. So we're just going to go ahead and pick or create a new class by extending the student class. So what we're going to do is we're going to build a class that extends the functionality of our existing student class. Okay? And in this case, what we want to do is create a frosh subclass of student. So we want to create this subclass here called frosh that is a student, which means it's going to extend student. Okay? So frosh will have all the same properties that regular students do, except for the fact that they start with 0 units. And I'm sure like many of you are sitting out there going, oh, no, Maron. There's this wonderful thing called the AP exam. Yeah, let's just pretend the AP exam didn't exist for the time being, because there actually are some people, as sad as it may be, that start with 0 units. And so we're just going to say that all frosh start with 0 units. Think of this as the number of units you've earned at Stanford. And I know there's even a few of you out there who've earned a non-zero number of units at Stanford, but let's just say it's 0. Be thankful it's not negative. You're like, oh, you're a freshman. You get -5 units. Thanks for playing. Now, the one thing we're going to do is we're going to specially designate frosh in the strings that display an object. So that toString method we talked about, that it has the name of the person and their ID number. For the case of frosh in particular, we're going to actually designate them as frosh just because your RAs love you and they want to know who are the frosh, right? So we're going to have to find a way of saying, hey, if you want the string version of this object, we're going to actually have the string contain the word frosh in it. Okay, so here's how we might do that. First thing we're going to do is we need to define the frosh class. So it's a public class, frosh, that extends student. So every frosh is a student. And then inside here, we need to have a constructor for the frosh class. Okay? Or, well, to create an actual frosh. It's not going to bring the entire class into being at once. It's going to bring each individual freshman into being. And it's going to take in a name and an ID, just like a regular student does. Now, here's the funky thing. Okay? What's the super thing all about? Okay? If we're going to initialize a freshman, what we need to say is, hey, as a freshman, we're going to initialize you. We're going to set your number of units to be 0, because that's one of the properties the freshmen have, is their number of units start at 0. But you're also going to have the same initialization done to you that all regular students do. So how do I refer to the initialization process or the constructor that regular students go through, right? Because I'm writing a special constructor for frosh, and unless I specifically say go and do the same things that you would do for a regular student, they won't happen. So the way I specify that is I say super, which doesn't necessarily mean like you're super, although it could, because as freshmen you're pretty super. I don't know if when you got your acceptance letter there was like that little handwritten note on the bottom. I remember when I got my acceptance letter, it was a different dean than there is now, and on the bottom it said super Maron, and I think that was the last handwritten thing I ever got from Stanford. So super means call the constructor of the superclass. Okay? So by calling super name and ID, what we're doing is saying, what's the superclass of frosh? It's student. So this will call the superclass of frosh, which is student, with name and ID, which means it's going to go through that initialization process of setting name to be equal, or setting student name, that instance variable, to be equal name, and student ID to be ID. Okay, the stuff that we did back over here. So let's just hop back over here for a second. The things that we do in the constructor of a student. Right? So all of this stuff we still want to happen for freshmen, which is when we say super name and ID, it's actually calling essentially this function to initialize all of the fields of a regular student, and then it's going to do some more stuff specifically for freshmen. So when we come back over here, and do our little super dance, what we get is essentially the constructor of a student being called to set up a student. This happens to be a freshman, which is a particular case of student. So we're going to do some additional work by setting the number of units equal to 0. Okay? So that's how we set up the constructor. Now, the other thing I mentioned was we need to set a toString method. Now, here's the funky thing. You might say, but Maron, students already had a toString method, right? So if I didn't do anything here, wouldn't all frosh be able to give me a string version of what they are? Yeah, they would. But we want to create a specialization of it. So what we do is we do something called overriding. And overriding just means even though your superclass already had a method called toString, in the subclass, I'm going to define a new version of that method. If the method has the same name and the same set of parameters, which in this case happens to be none, it does what's called overriding, which means for all objects that are of type frosh, when you call toString, you're going to call this version of the method. The version that exists in the student is no longer germane for frosh. It's still germane, say, for sophomores or juniors who may not implement their own version of toString. But for frosh, it's going to call this version of it. So overriding just means forget about the old version. I'm sort of overriding it with my new funky version that's specific to this particular subclass. Okay, any questions about overriding? Has to have the same name for the method and same parameter list. So what we do here is, remember, student ID and student name are private. Now, the funky thing about private is even when I extend a class, when I create a subclass, that subclass does not have access to the private elements. And you're like, whoa, Maron, that's kind of weird. Like, I have a student, and inside a student, I can like play around with student name and student ID. But as soon as I create this thing called frosh, which is a subclass of student, it doesn't have access to those private elements anymore. Okay? Which means if I want to be able to get the name and the ID of the student, I can't just access the variables directly. I need to access the corresponding getters, get name and get ID. So now if I call toString, what I'm going to return is a string that says frosh colon and then your name and ID number. So that's how it differentiates it from the standard version of toString. Is toString, the regular one just provided name and ID number. This one actually sort of designates you as a frosh because we know you're a member of the frosh class. Okay? Any questions about this notion of public versus private and why in a subclass you still can't access the private portions? Is there a question over there?
Yeah. So in return values that are privately stored in a superclass, but it can't access them just like a superclass.
Yeah, so the way you can think of a subclass is just another class. So the visibility that it has into its superclass is the same visibility that any other class would have. Okay, so it can't access the private portions directly, even though it's a subclass. It needs to call public methods to be able to access those elements. It can still access any of the public elements. It just can't access the private elements directly. Okay, which is kind of funky. That sort of freaks some people out. And there's this thing called protected that eventually we'll get into, but we won't talk about it right now. All you need to worry about is private and public. But if you sort of extend the class, if you create a subclass, you need to understand that the subclass does not have access to the private elements. Alrighty, any questions about that? Are you feeling okay with that? If you're feeling okay with that, nod your head. Alrighty, we're mostly head nodding, so that's a good thing. Alright, so what I want to do now is it's time for us to draw pictures. It's just a lovely thing. This is really a day that's about graphics, and graphics is all about drawing pictures. And a matter of fact, for your last assignment, you drew a bunch of pictures, right? You, in assignment number 1, you drew some stuff that used the graphics library and life was all good. So we're going to revisit that drawing that you just did for your last assignment and just soup it up. We're going to bump it up so you can do all kinds of funky things like animation and games, and eventually we'll get into like where you can read mouse clicks and the whole deal, and you will just be good to go. But we got to build up from where we sort of started before. So where we started before was the ACM graphics model, right? Which is when you were writing graphics programs, you were using the ACM graphics model, and we talked about this before. It's a collage, right? You basically start with this empty screen, and you basically put little, felt pieces onto the screen. So you say, give me a square, and give me an oval, and throw it somewhere else. And you just kind of add these things to a little canvas, which is your empty screen to begin with. Okay? Now, A couple things that sort of you may have noticed as you were doing the last assignment, or you'll certainly notice here, newer objects that we add. So when we add things to our canvas, if it happens to obscure something else, that's fine. It'll just obscure it. The newer things are sort of laid on top of the old things. And this is something that we refer to as the stacking order, or sometimes referred to as the Z order, because if you're sort of like a Cartesian coordinate system person, the Z-axis comes out toward you, right? Here's the X-axis, here's the Y-axis, the axis comes toward you, which imagine if you stack these things on top of each other, if you think in 3D, that's kind of the Z-axis. But if you don't think about that, think of these as just pancakes. You're laying on top of each other, and you're stacking them. And the new stuff occludes the stuff behind it. Okay? And that's what we refer to as the stacking order. So hopefully this is all review for you. And as a matter of fact, this stuff should all be review, right? Many moons ago, say 2 weeks ago, a week ago, we talked about ACM graphics, and we said there's this thing called a G-object, and a bunch of things that inherit from G-object are G-label, G-rect, G-oval, and G-line are all subclasses of G-object. And everyone was like, oh yeah, I remember that, it was a good time. Like I was creating these objects, I was adding them to my campus, it was just fun. And then you look at this diagram and you say, hey Marin, why did you draw it so funky? And the reason why I drew it so funky is there's a whole bunch of other stuff that now it's time for you to learn about. Okay? So here's kind of if we think about the ACM graphics package in the large, and you're like, oh man, there's like points and dimensions and compounds and these 3D rectangles and all this stuff going on. You don't need to worry about all that stuff. Okay? There's just a whole bunch of stuff that comes along with Java and the ACM libraries. And it's kind of like, you know, you're out there and you wanted to buy like the basic car, and you got the car and they put this jet engine on top of it. And you were like, that's really bad for the environment. I just really want to be able to drive my car without the jet engine. They tell you, okay, well the jet engine's there, but you never have to turn it on. And you're like, all right, that's cool. And that's what we're going to do. All right? So all the stuff you see in yellow is stuff we're going to talk about. And the rest of the stuff isn't really the jet engine. Right? It's not that cool. Really, the rest of the stuff is like, you know, like 70s racing stripes and like a big hood scoop and stuff like that. It's like, yeah, you could have it on your car if you really wanted to, but probably not in the 21st century. So we're going to focus on all the stuff that really is kind of important for what we're doing. And there's a few other things you can read about them in the book, but we're not going to spend class time on them. You're not going to worry about them in this class. If you really want to know, you'll know. But we're going to do all kinds of cool stuff with like images and polygons and just things that will be interesting, hopefully. Okay? So with that said, let's first talk about this thing called G-canvas. And G-canvas is this thing that kind of sits up there. And you're like, yeah, G-canvas is not one of these objects that I sort of put, you know, that I kind of create and put up on my collage. What's that all about? So let's talk about that and get that out of the way, and then we can focus on all these other things that we can kind of draw and put up on our board or our little canvas. So what a G-canvas is it represents, in some sense, the background canvas of the collage. It's the big piece of felt that we're going to put all the other little shapes on top of. Okay? And you might say, but Maron, didn't we already have one of these? When I create a graphics program, don't I already get sort of my empty canvas that I put stuff on? Yeah, in fact you do. What a graphics program does for you automatically, just because it loves you that much, is it automatically creates one of these G-canvas objects and makes it large enough to fill the entire program window. So actually when you're adding your objects to a graphics program, you're actually adding them to a canvas or a G-canvas object. The graphics program has just created one for you seamlessly, so up until now you never had to worry about it. And as a matter of fact, for about the next 5 weeks you're not going to have to worry about it. Well, 2 weeks you're not going to have to worry about it. Okay? And so you might say, but if that's the case, when I was calling add, weren't my add call methods, like when I was calling those, weren't they going to a graphics program? Because I never worried about this thing called G-canvas. Yeah, in fact, they were going to the graphics program. The graphics program had a method called add, and when it got it, it said, hey, you want to add an object? I'll pass them over to the G-canvas I created. So what it was really doing was forwarding, just like you think of call forwarding. You get a call from your friend, you're like, oh yeah, you want to talk to Bill? This isn't Bill. Let me forward you over to Bill and you can talk to him. They called the add method on graphics program. Graphics program said, oh yeah, you want to add that? Well, the person who really takes care of the adding is the canvas. So I'll just call canvas, passing in the same arguments to canvas that you passed to me. That's called forwarding. It's basically just some method that sits there that actually passes all the information that goes to it to someone else to actually do the work. We also refer to that in the working world as management. So you basically forward on to something else that does the real work. Okay? And so forwarding, to put it in the speak of object-oriented programming, is when the receiver of a message, right? So before, graphics program was the receiver of the message, then calls some other object with that same message. Okay, so that's how we'd say it to sound real funky and get paid more money. All right, same kind of idea. So it turns out that gcanvas and gprogram, graphics program, which is really just forwarding a bunch of your calls over to gcanvas, support a whole bunch of methods, some of which you've seen. I want to give you the quick tour. So there's add. You've certainly seen that. It just takes some object, some g object, like a grect or a g label, and adds it to the screen. And you can add some object at a particular xy location if that object doesn't already have some existing xy location. So there's two versions of that method. Up until now, we've told you how to add things. Now you're sort of old enough to actually take, it's like training wheels, right? Before you could add training wheels, now you can remove the training wheels. So for an object, you can actually say remove, and it will take that object off of the canvas. Just rips it right out. And if you want to get really funky, if you're having a bad day and you just come in there and there's like this nice picture of bunnies and flowers and stuff, and you just say, no, man, that's not my world. Remove all. It's just all gone. All of the objects you put on that canvas is sort of like, it takes the canvas outside, shakes it out, and all the little fluffy bunny pieces go away, and it's remove all. It just clears it. Okay? There's get elements at, and this is a very funky thing. You will use this in breakout. Pay close attention. What get elements at does is you give it a particular XY location, a pixel location on the screen. What it will return to you is the frontmost object at that pixel location if one exists on the canvas. If one does not exist on the canvas, it will return to you something called null. And null just basically means no object. Okay? You can assign null to something of type gObject, but that just basically means that gObject that you're trying to deal with is just like there's nothing there. Okay? Otherwise, it will actually give you back a gObject, which could be a specific thing. It could be a grect, a goval, a gline, whatever it is. But all of those grect, goval, glines are all of type gObject. So in fact, even if it gives you a grect, it's still giving you a gObject back, because a grect is just a specialization of a gObject. So it will actually give you back an object that's at that XY location. That might be real useful, for example, if you're playing a game that has a bunch of bricks across the screen, and when your ball is supposed to be hitting one of the bricks, you want to check to see, is there actually a brick there? You could call get elements at, and if there's some little brick, which is actually, say, a grect, it will give you back that grect object, which then, for example, you might want to remove. Okay, just a few hints.
On the XY coordinate, it's not the XY coordinate that's the top left-hand corner, right? It's just
this is an XY coordinate of the whole screen, of the canvas. And if there is some object at that XY coordinate anywhere, if that point has an object that point is encompassed by that object, it will return the object. And just the foremost object. That's why you care about the stacking order, because if there's multiple objects there, you get the frontmost one. Get width and get height you probably knew about when you were centering stuff, right? Gets the width in pixels of the entire campus and the height in pixels of the entire canvas, which is for the entire screen if you're talking about a graphics program. And set background color, that's kind of new, kind of funky. You want to set a different background color than white, you just pass in a color and it will set the entire color for that canvas, or the entire window in the case of a graphics program, to that color, which is kind of fun. Okay? Now there's a couple other things that only graphics programs do. Gcanvases do not do these, just graphics programs do them, and they're very useful for games and animation. One is called pause in milliseconds. What it does is, because computers these days run real fast, if you ran a game without any pauses in it, people would just not be able to play the game. So you can pause for some number of milliseconds, which is thousandths of a second. So what it does when it gets here is it basically just sort of stops execution for some number of thousandths of a second and then keeps going. So it allows your programs to kind of slow down a little bit to make them playable. And sometimes you want to wait for a click, and there's strangely enough, a method called wait for click, and it suspends the program. Basically, your program just stops executing until someone hits the mouse button, and then once they click on the mouse, it keeps executing again. Okay? So those are some useful things for games, or even for debugging sometimes if you're doing a graphics program and at some point you want to stop and say, hey, let me stop the program here and see how far it's gotten, and I don't want it to go any further until I click. You could just stick a wait for click call inside your graphics program. Okay? So here's the class hierarchy for just the gObject. This is the stuff we're going to focus on here, right? You've already seen glabel, grect, goval, and gline. We're going to spend a little bit more time on glabel to get into the specific nuances of it, and then we'll talk about some of the other stuff as well. Okay? So here are some methods that are common to all gObjects. So everything that is a gObject, which includes all of this stuff, is going to inherit all of these methods. Okay? So a lot of these you've seen before. Set location for an object, you set its x and y location. Move, which you set its offset by some dx and dy, which is just how much in the x direction and how much in the y direction your object should move. That's real useful for animation, and I'll show you an example of that in just a second. Okay? Get x and y. This just returns the x coordinate of the object and the y coordinate of the object, okay, which for example would be the upper left-hand corner for something that's large. Get width and height. This is actually pretty useful. It turns out, if you have some rectangle, you know what its width and height are. Later on, you might want to, if you forget to store them, you could actually ask it what's your width and height. This is actually really useful also for text, because if you want to draw some piece of text centered in the screen, you actually don't know how big those characters are until you actually figure out what its font is and all that stuff. So a lot of times you want to create your text. I'll show you an example of this momentarily. And then after you've created the G label, say, hey, what's your height and width so I can center you appropriately in the screen. Contains, which is also kind of similar to get element at, but a little bit different. It actually returns true or false. It basically returns true if an object contains the specified point. So this is a method you call on a particular object. So you can tell like some rectangle, hey, do you contain this point rectangle? And it'll say yes or no, or true and false if it actually contains that point. Okay? Set color and get color. Hey, it's a pair of setters and getters, just like you saw with students. Question? Pardon? It has to do with what the particular shape is yourself. So this is one of those things where I would ask you to actually do it experimentally, right? So there's a lot of things you can just try out. Just try the experiment. If you want, you can read it in the book, but it's actually more fun to try the experiment because you'll get some somewhat funky behavior. All right, sorry. Get color and set color, as you would imagine, sets the color of the object or guess the color of the object. Here's one that we haven't talked about so far. It's kind of funky. Set visible and is visible. So set visible, you set it either to be false or true. If it's false, the thing becomes invisible. If it's true, it becomes visible. You might say, hey, Maron, how is that different than remove? I thought remove takes an object off of the canvas. This is not taking an object off of the canvas. It's just making that object invisible, which means if you want to have some object on the campus and flash it, for example, to be there or not be there, all you need to do is set its visibility to alternate between true and false. You don't need to keep removing it and adding it back on, because removing it and adding it back on potentially changes the Z order, right? Because that object now gets tacked onto the front. If this object was in the middle somewhere, you don't want to change its Z order by removing it and tagging it back onto the front. You just want to make it invisible where it is. And you can ask an object for its visibility. Last but not least, if you want to change that Z order, if you're actually a big fan of drawing programs, a lot of these methods will look familiar to you. Send to front and send to back brings an object either the front or the back of the Z order. Send forward or move forward moves it back one level in the Z order if you want to actually just reorder stuff in the Z order of objects.
If you set an object to be invisible and then you try and ask it to contain certain points.
I knew you were going to ask that. Try it. Try it and you'll find out. Alrighty. Because a lot of these things are actually interesting, and then you realize that you probably would never do this in real life. But if you want to try it out, it's more fun to be experimental than just giving you the answers for a lot of these things, because then you'll never try it. So I want you to at least try a few of them. Methods defined by interfaces. What does that mean? What is an interface? So there's this funky notion we talk about in computer science, or actually it has a specific meaning in Java. We talk about it in computer science in general as well, but it's the notion of an interface. And an interface, sometimes people think of, oh, is that like a graphical interface? Is that like, using my mouse and little things that appear on my screen? That's one kind of interface. That's an interface that humans work with. There are interfaces that programs work with. And basically all an interface is, the way you can think about this, is it's a set of methods. Okay? That's what, in some sense, defines the interface. And why do you care about defining some particular set of methods? Because what you want to be able to say is there's a set of objects or set of classes that all have these methods. So you have some set of classes that have that set of methods. Right? That seems like kind of a funky thing. Why would you want to do that? You might say, well, hey, Maron, there's kind of a similar concept, right? Isn't that whole concept of inheritance you talked about sort of like this, right? Because if you have over here your G object, and you have something that's a G label, and you have something else that's a G rect, you told me a G object has some set of methods. So doesn't the fact that G label and G rect are both G object, aren't they some set of classes that have the same set of methods? Yes, that would be true. And so then you might ask yourself, so what's different about this thing called an interface than just inheriting from some class? And the difference is that sometimes you want this set of methods to be shared by a set of classes which don't have this kind of hierarchical relationship. Okay? So an example of that might be, for example, a class called an employee. And students, for example, can be employees, but there can be people who are not students who are employees, okay, as well. And there might be some entirely different class of people who are employees. So if I had something called an employee here, and I might say, hey, well, at Stanford, I have a bunch of different specializations. Like I have my Frosh employee, and I have my, other employee over here that's a senior employee. And then Stanford comes along and says, yeah, but there's also this thing called a professor, and not all professors are employees. And you're like, really? Yeah, sometimes it happens. It's weird. Trust me. Okay? But it turns out that sometimes you could not only have, some person who's a senior employee who's an employee, but some person who's a senior employee who's also potentially a professor. And you're like, but professors have some methods associated with them. Not many, but they have some. Employees have some methods associated with them. So there's these different sets of methods that I want, for example, to have one of these guys to be able to share, but there isn't a direct hierarchical relationship. That's what you specify in an interface. You basically just say if interface is the set of stuff, and I'll tell you which classes actually provide that set of stuff. And they don't have to have any kind of hierarchical relationship. It's just a way of decoupling the hierarchy from having some set of common things that you'd like to do. Okay? So let me show you some examples of that in the graphics world. Okay? So there's something called gfillable. That's an interface. So gfillable is a set of methods that a certain set of classes have, and the certain classes that have it are a garc, a goval, a gpolygon, and a grect. Okay? So notice you might say, hey, Meron, yeah, those are all g-objects. Why isn't everything that's a g-object g-fillable? Because there are some things like a g-label that's a g-object that's not fillable. Okay? So that direct hierarchical relationship doesn't hold. I have some subset of the classes that actually have this. And fillable are just the things that can be filled. So set filled, I set to be either true or false, just like you've done with grects or govals in the past that fills it, that either sets it to be just an outline or filled. I can ask it if it's filled by saying is filled. That returns a Boolean, true or false if it's filled. I can set the fill color. I can get the fill color. Getters and setters, once again, rearing their ugly heads. So fillable is just a certain set. It's an interface, and there's a certain set of classes that what we refer to as implement that interface, which means they provide all the methods in that interface. And there are some other interfaces, like there's resizable. Gimages, govals, and grects are resizable, which is kind of funky. And resizable just means you can set their size, so you can set the dimensions of the object to be different after you've created the initial version of the object. Or you can set the bounds of the object, which is both its location and its width and height. You can change those after you've created the object. Right? A glabel I can't do that with. Okay? And there's one more set of interfaces, which is called scalable or g-scalable. And a whole bunch of things actually implement g-scalable or provide for you the set of methods in the g-scalable interface. Garcs, g-compound. Some of these we haven't even seen before. You're like, Meron, what's a garc? Don't worry, we'll get there. You've seen g-line, you've seen g-oval, you've seen g-rect. You'll get all the other g's in there. It's all about the g today. That's just what's going on. And so you can scale these things, which you give it some scale factor, which is a double. A value of 1.0 means leave it unchanged. That's basically 100%. Now you can potentially scale it. If you give it a value like 0.5, it means shrink it by 50% in the x and y direction if you give it this version. If you give it this version, you can actually set the scaling in the x and y direction to be different. And I'll show you an example of that momentarily. It's kind of funky. It's fun. You can distort your pictures. It's easy. It's one method. All right. So let me give you a little animation just to put a few of these things together. A little bouncing ball. So if we come over here, and you should have the code for this in one of your handouts, I'm going to create a little bouncing ball, and I'll go through some of the constants pretty quickly. The ball has a diameter and some number of pixels. There's a gravity, which is at every time step, how much more quickly is the ball going downward, how much it is affected by gravity. So every cycle, its speed is increased by 3. Some delay in number of milliseconds for the bouncing ball, otherwise it'll just go way too quick and you won't see it. So we'll have a 50-second millisecond delay between every update of the bouncing ball. The starting x and y location of the ball is basically just at, y is at 100. The x is near the left-hand side of the screen because it's basically the ball's diameter divided by 2. The ball has a constant velocity in the x direction, which is 5. And Every time the ball bounces, it loses some speed. So how much of its speed does it keep? It keeps 90% of its speed, basically. That's what the ball bounces. It's just what fraction of its speed does it keep as it goes along. And so our starting velocities for x and y, or the x velocity is never going to change. It's just going to be set to be whatever the starting x velocity is. We're never actually going to change it. The y velocity, which is how much the ball is moving in this direction, starts at 0. And over time, it's going to increase until it hits the ground or the bottom of our screen. And then it'll bounce up. And we'll see how to implement that. And our ball is just a little g oval. So I'm going to have some private instance variable that's a g oval. That's the ball I'm going to create. And then I'm going to move it around. Okay, so what am I going to do? First of all, in my program, I'm going to do this thing called setup. What does setup actually do? So when I do the run, I call setup. What does setup do? Setup says create a new ball at the starting x and y location with the given diameter in both the height and the width. Okay, so it's basically just creating a circle at that location. It sets the ball to be filled, and it says add the ball to the canvas. So basically all setup does is it adds a ball somewhere, an oval, a g oval, that's filled somewhere onto the canvas. That's great. That's all setup does. It created the ball, added to the canvas. Now, how are we going to animate it? The way we're going to animate it is as long as the ball's x coordinate is not yet the width of the screen, which means the ball is going to sort of bounce across the screen like this until it's gotten to the end of the screen. I'm just going to keep running the animation. Once it sort of bounces off the right-hand side of the screen, game over, right? It's gone past the width of the screen. So what I'm going to do on every iteration is I'm going to move the ball. I'm going to check for a collision to see if the ball has hit the bottom of the screen. And after I check for collision, right, which is if it hits the bottom of the screen, I need to send it back up, I'm going to pause before I move the ball again. So that's my cycle. Move the ball, check for collision, wait. Move the ball, check for collision, wait. Sort of like standard animation. Okay? So what does move ball and check for collision do? Move ball is extremely simple. It just says, on every time step, I increase how fast the ball is going down, which is its y velocity, by gravity. So I plus equal its current y velocity with whatever gravity is. Question?
Why do you clear the oval at the top and then like
Well, when I declare it, right, all I've said is set aside the space for that object. When I say new g oval, it actually creates the object. So I need to create the object before I can use it. By just declaring the variable, I haven't actually created the object. Okay? So up here, when I declare this g oval up here, this private g oval, that just says give me the box that's going to store that object that's a g oval. I don't actually fill it up with a g oval until I do the new. Okay, so I have to do that new to actually create the object. So move ball, I just showed you, right? We accelerate by gravity and we move the ball in the x direction and the y direction, right? The x direction is always going to remain constant, so the ball is just slowly going to move across the screen. But its y velocity is going to change because it's going to bounce. Check for collision looks way more funky than it is. Here's all that's going on in check for collision. I check to see if the y coordinate of the ball is greater than the height of the screen minus the ball's diameter. If it is, that means the ball has not hit the bottom of the screen yet, right? Because it's if it's greater, it means the ball has hit the bottom of the screen because it would be below the bottom of the screen because y coordinates go down. So if the ball's y is greater than the height of the screen minus its diameter, right, because we have to give the ball some room to be able to hit the bottom of the screen, which is its diameter, then if it hasn't fallen below the floor, there's nothing to do. If it would have fallen under the floor, then what I do is say, hey, you're going to bounce off the floor, which means when you hit that floor, change your y velocity to be the negative of what it was before, which means if you were going down before, your y was increasing, now you're going to be going up or your y is going to be decreasing. Okay? So change your velocity to be the negative of what it was before multiplied by the percentage of your bounce that you're keeping, which is 90%. Right? So it's going to slow down every time it bounces in terms of how far up it's going to go, but just by whatever this percentage is. But the important thing is you need to reverse its direction because it's bouncing off the ground. Last but not least, and this is just kind of a minor technical point, but I'll show you anyway, it's all in the comments. If the ball would have fallen through the floor, like it was actually moving so fast that it actually was like here in one time step and the next time step it would have been below the floor, we just say take the difference from the floor and pretend you already bounced off the bottom. So we'll just kind of add that over to the top side and you'll just essentially take that amount that you would have bounced through the floor and say the bounce already happened and go back up. Slight technical point, but this is the math that does it. Not a big deal. What does this actually look like? It's a bouncing ball. Oh, animation, right? You can play games, and then the simulation ends when it goes off that end of the screen. Okay. Okay? It's just so cool. You just want to run it again, but I won't because we have more stuff we want to cover. But now you too can bounce the ball, and you can like make it different colors, and every time it hits the bottom, you can set random color, and your ball like changes every time it hits, and it's like, oh my God, there's so much I can do. It's so cool. Yes, there is, and we won't explore it all right now. But what we will do is explore a couple more things. Okay? So, our friend the G-label class, you're like, oh, but Marilyn, I already saw the G-label class, right? I've been doing G-label since the cows came home. I did G-label on this last assignment. I know how to create a new label at a particular location, to change its font, to change its color, and to add it. So what new are you going to tell me? And on that slide, I'm not going to tell you anything new. What I'm going to tell you new is on the next slide, which is what's the actual geometry of this G-label class if you want to center stuff in the screen, for example. So there's a bunch of typesetting concepts that are related to G-label. First of them is the baseline. The baseline is basically the line on which the text appears. But notice there are some things that actually go down below the baseline. That's the way typesetting works. You actually have a baseline. Some characters like a J or a P go below the baseline. So when you're setting up a particular G-label, the value that you set for where that G-label should actually be placed is the origin of the baseline. It's the far left-hand corner of the baseline. It's not down where you get these descending characters. It's the baseline that most characters are actually sitting on. So then you say, well, how do I get like the descent and the ascent and all this other stuff? Well, before you do that, the height of a font is its distance between two successive baselines. Okay? But more importantly, if you're just trying to center one line in the screen, you care about two things called the ascent and the descent. The ascent is the amount above the baseline by which the tallest character can actually reach. Okay? The descent is the distance that any character will drop below the baseline, right? So for Y's and G's and J's and stuff, you actually have some non-zero descent, which is the amount below the baseline. So if you want to figure out how big something is, usually when we center stuff, we just care about the ascent. We don't actually care about the descent. So if you want to center something, here's an example of centering something. We again have our little text, hello world. We set it to be big, we set it to be red. Notice we haven't figured out where on the screen to put it yet, because we're going to compute that after we set the size of the font. So we know how big it is. Now we can ask this label, how big are you? How wide are you? How tall are you? So to get it to display right in the center of the screen, its x coordinate is going to be the width of the whole screen minus the width of the label, right? So we're going to take the width of the whole screen, subtract off the width of the label, and divide the whole thing by 2. That'll give us this location right here. The other thing we need to do is figure out how to center relative to the height of the characters. What we do is we get the ascent. We don't care about the descent of the character. Standard typesetting kind of concept, but now you know. You get the ascent of your font, which is how high it goes above the baseline. You subtract that off from the width of your window and you divide by 2. That will tell you what the point is right there in terms of the y direction to be able to figure out how to center this text. And then you add it at that particular xy location. Okay, so now that you know how to actually make your font bigger or whatever, you can figure out the size of your text so you can appropriately space it on the screen. Okay? A couple more things before we wrap up for today. Last thing I want to cover is this thing called the G-arc class. What is a G-arc? Actually, there's a couple things I want to cover. The G-arc class is basically just drawing an arc somewhere. It's a little bit more complicated than it looks. Friends of mine who are artists tell me that you can draw everything in the world using just straight lines and arcs. Is that true? Yes? No? Maybe? Let's just pretend it is. You already know how to draw a line, right? You have G-lines. So now that you know how to G-arc after a couple more slides, you can draw anything in the world. It just might take you a whole bunch of little objects to draw it. Okay? So an arc is formed by taking a section from the perimeter of an oval. What does that mean? Okay? Basically, it looks something like this. The steps that are necessary to define that arc is we specify the coordinates and size of some bounding rectangle, just like you did with a G-oval, right? A G-oval sits inside some rectangle, and that's what tells you what the dimensions of the oval are. Here I've drawn it as a circle. So here's the bounding rectangle, and it's got some upper left-hand location. So we have some XY upper left-hand location. We have a width and a height. Okay? That's what's going to define for us what essentially the oval is going to look like. But we're not going to draw the whole oval. We're just going to draw an arc from the oval. How do we specify the arc to draw? We need to specify something called the start angle and the sweep angle. So what are the start and sweep angle? Both of these angles are things that are measured in degrees starting at this line. So starting at the x-axis. Okay? So if I say my start is 45 degrees, it goes up 45 degrees and says your start would be here. Your sweep is what portion of the oval you actually draw out in degrees. So if I set a sweep of 180, I will draw out a semicircle because I'll draw 180 degrees starting at the 45 degree mark. Okay? And it always draws in the counterclockwise direction if you give it positive values. If you give it a start value or a sweep angle in negative values, it will start on the other side and go in the clockwise direction. So let me show you some examples of that, because that's kind of a big mouthful. What does that really mean? Here's just a few examples so you know. We're going to draw some arcs centered in the middle of the screen. So we're going to figure out CX and CY. Let's just assume they're the middle of the window. We already computed them using get width and get height. And D, which is the diameter of the oval we're going to be using, or the circle in this case, is just pre-configured to be 0.8 times the height of the screen. Okay? So if we do something like we say, create a new G arc that has its bounding box being D and D, that basically means we're going to have some oval that's height and width are both the same being D, which means it's just going to be a circle with diameter D. We're going to start at the 0 degree arc. Remember, 3 o'clock is where we start, 0 degrees. And we're going to sweep out an arc of 90 degrees, and that goes in the counterclockwise direction because it's positive. So we get an arc that's essentially this little quarter of that circle, because it's 90 degree arc starting at 0 degrees. Okay? There are some other things we could do. We could, for example, say, hey, you know what I want to do is start that same circle to the same size, right? Its height and width are both D. Start at the 45 degree mark. So coming up 45 degrees from sort of this 3 o'clock mark is right there. Have a sweep of 270 degrees. So we get this big portion of the circle and it looks like a giant C. But that's 270 degrees of the circle. We can do some slightly more funky things using negative numbers, for example, where we say, draw a new arc. Your starting point is negative 90 degrees. What does that mean? It means 90 degrees going clockwise. So I start at 3 o'clock, I go 90 degrees clockwise, that's right here, and then I sweep out an arc of 45 degrees, which is counterclockwise because it's positive, so it sweeps up 45 degrees. Okay? One more for the road. This one says start at 0 degrees and set your sweep to be negative 180 degrees. So if it's negative 180 degrees, it goes in the clockwise direction, 180 degrees starting from 0, and we get this thing that looks like half of a circle or a smiley face. Okay, so any questions about gearc? There's all kinds of stuff you can do with gearc, but at least if you understand the basic geometry, hopefully it'll make sense.
Why can you fill a gearc?
You can fill a gearc. So last slide before you go, okay, is a filled gearc. Good question. Basically, if you write a gearc, whatever that gearc is, and you set its filled to be true, what you get instead of just the arc is you get the pi wedge that you would have gotten associated with that arc. Okay? So just imagine you had some solid line that sweeps out the arc. That's what you get with the filled version of a gearc. Any questions? All right, then I will see you on Wednesday.